Interesting day, a day that the Lord has made, and today we want to look at a very interesting part of ODE. We want to look at a very interesting part of ODE that is called second order differential equation. Yeah, second order differential equation. But you see, many problems in engineering gives rise to second order differential equation. And when I mean second order differential equation, what I'm trying to say is that we have a the squared y over the x squared plus b the y over the x plus cy is equal to f of x. This is what I mean when I say second order differential equation. So as we have seen it here, we now begin to understand what we are talking about in details. Now in this particular example that I just cited here, or in this particular form, we all know that this is a second order differential equation. In this form, you will discover that a, so let me put it, where a, b, and c are constant coefficients. They are constant coefficients. Let's put it that way. And f of x is a given, let's put it that way, is a given function. F of x is a given function of x. And so by the end of this particular topic, we would have broken everything you need to note down for easy understanding. Is that clear? So now let us look at f of x is equals to 0. Let's start from there. F of x is equal to 0. Then the equation that we're talking about becomes, the second order differential equation we're talking about becomes a, just like I wrote it there, the squared y over the x squared plus b, the y over the x plus cy is equal to f of x. That is when f of x is equal to 0. Now, this is called, the name of this is called a linear, it is called a linear constant coefficient, second, let me give it the full name, second order homogeneous, a linear constant coefficient second order homogeneous differential equation. That is what it is called, differential equation. Did you see that? So having said all of this, we shall now look at the solutions to this particular equation. So let's look at it together. You see, we can say let y equals u such that y equals v. Now u and v are functions of x, right? So what I mean by let y, so let me replace y as u. Remember when we were doing homogeneous, when I said y is equal to vx, right? Vx substitution. Now I started an example there and we used some illustrations to buttress that example. Now when we come to second order differential equation, when we look at this particular function here, I'm just trying to tell you that this particular equation there that you're looking at is a second order homogeneous. Now to solve that, we say let y equals u and let y equals v, right? So what we can say is that we can do this. Therefore we now have a, the squared u, no longer y, over the x squared plus b, the u dx plus cu is equal to 0. We can also have a, the squared v over the x squared plus v, dv dx plus cv is equal to 0. We can have these two things. Now when we add these two things together, when we add them up together, adding them together, we then have a into the bracket of the squared u over the x squared plus the squared v over dx squared plus b into the bracket of du dx plus dv dx plus, let's continue, plus c. See what I'm doing? From here to here, from here to here, from here to here. We are doing the addition. Is that clear? So c into the bracket of u plus v equals to 0. Is that clear now? So now from there, what can happen here? What can happen here? We can now say that d over dx of u plus v is equal to du dx plus dv dx. Do you understand? We are multiplying this to this, this to this. So du dx plus dv dx. And when you now say d squared over dx squared, second differential, that's u plus v, you're going to have the squared u over the x squared plus the squared v over the x squared. So second differential, this is as the first differential, this is as the second differential. You see that? So therefore, at this junction, therefore, let's put it that way, therefore, our equation, or the equation, can be written as, is written as a d squared over the x squared into the bracket of u plus v plus b d over dx into the bracket of u plus v plus c into the bracket of u plus v is equal to 0. So the equation can be written as this. Now if we write it like this, it means that our original equation where we have y can be replaced. Now if we can write it like this, it means that our original equation where y is present, our original equation where y is present can be replaced. You see, can be replaced with what? Or replaced by, can be replaced by u plus v. That means if y is equal to u and y is equal to v, our solutions for the equation will be this. So if y is equal to u and y is equal to v, our solution to this function will be a the squared y over the x squared plus b the y over the x plus cy is equal to 0. Do you understand? So it's a very important thing that you should be referring to when you are reading. Do you understand? You should. So now when you have this, I know at this point, right, at this particular point, I know you have not still gotten a picture of what we are doing, but just follow us. It's going to become very clearer. As you follow, it becomes clearer. Now when you have this, when you have something like this, our equation has been derived, right? If a is equal to 0 and b is not equal to 0, right, we will get a first order equation of the same family. We will get, let me write it there, we will get the first order equation, of the same family, Yes, if a is equal to 0 and b is not equal to 0, we will get the first order equation of the same family. What do I mean? So if you say b dy over dx plus cy is equal to 0, remember that we have said a is 0. So if you say 0 multiplied by this, that's 0, right? So look at it. B dy over dx plus cy is equal to 0. That's a first order differential equation. We all know that, right? That's a first order differential equation. That is, it means that dy over dx plus ky is equal to 0. If k is equal to c over b. Did you see that? Now, enough of all my story. My point, or the main thing I'm trying to drive at, is the fact that from here it becomes very easy for you to do a separable variable. It becomes very easy if you do doing separable variable from here. If we do a separable variable from here, separable variable method. If we do a separable variable method from here, we're going to have dy dx is equal to minus ky, right? Because we're taking this one to the other side. If you take this to the other side, you can now have the differential of dy over y is equal to negative the differential of k dx. And so if you have this at this point, you will have ln y is equal to minus kx plus c. That's what you're going to have. And so taking the exponent of both sides, take the exponent of both sides. And so if you take the exponent of both sides, we're going to be having y is equal to exponent of negative kx plus c, right? And the laws of indices will tell us that this is negative kx multiplied by negative c, multiplied by e to the power of c, sorry. So this can now be likened to as what? Let me put it this way. Since e to the power of c is a constant, then you can now have ae negative kx. You can take this as a constant a, taking it as a what? As a constant a. So we have ae negative kx. That means our y is ae to the negative kx. Do you understand? Now, what we are saying that is that whenever we have a function, or whenever we have a second order ODE, we must be able to do what? We must be able to break it down such that it is solvable through any of the methods given. Remember, we have direct integration, we have separable variable, we have homogeneous equation, we have, quite a number of them, right? Now, all this story will not make sense if we don't get into the nitty-gritty of it. If we write the symbol of m for minus k, let's put it this way. If we write the symbol, write the symbol m for minus k, then what we'll be having is y is equal to x, because I've replaced minus k, this minus k here, I've replaced it as m. So I'm going to have y is equal to e to the power of mx. Now in the same way, if y is equal to e to the power of mx will be a solution of the second order differential equation, it means that it satisfies the equation, right? It means that it satisfies the equation. So now if you say this, that y is equal to e to the power of mx, then you can simply say that the y over the x is mx. Of course, sure, yes, product, then the squared y over the x squared is equal to m squared mx. Did you see that? Yeah, because we are differentiating twice. Differentiation of this will give you this. Is that clear? Now, if you substitute the expression back, by substitution, we're going to have m squared, yes, e to the mx plus b m e to the mx plus c e to the mx is equal to 0, right? So in the end, if you divide through, okay, let's divide through. Dividing through by e to the mx, we're going to have m squared plus bm plus c is equal to 0. Now that is a quadratic equation that has two values of m. Now let us say m is equal to m1, right? And let's say m is equal to m2. It means that is y is equal to ae m1x and y is equal to be m2x. Did you see that? And these people are the solutions of a given equation. Now, we already seen that if y is equal to u and y is equal to v are the two solutions, then you can say that y is equal to u plus v. You see that? So it means that if y is equal to a e to the power of m1x and the same y is equal to b e to the power of m2x, then our solution can be y is equal to a e m2x, sorry, let me put it m1x plus b e m2x. See that? See that? So this is the necessary arbitrary constant for second order differential equation. So there can be no further solutions. No further solution. So what I'm trying to tell you is the diving around a second order differential equation can be very dicey. It can be very dicey. So you must know that first of all, second order differential equations are quite different from first order differential equation in the sense that these people carry a second order. You should look at it there. And at a point when solving it, you must always know that there should be or there can be what we call auxiliary equations. So now, enough of our story. Let's get down into the business. So, first of all, example 1. All questions solved here are photo-pass questions. All questions we solve here are photo-pass questions. ODE, ordinary differential equation. Example 1. For the equation 2, the squared y over the x squared plus 5 dy over the x plus 6y is equal to 0. Now, our first step is to derive. Step 1. Let's look at it together. Step 1. You see, derive the auxiliary equation by replacing the y over the x as m. That's the first thing we're going to do. So let's do that. So we have 2. When you say dy over the x as m, so anywhere I see dy over the x, I'll put it as m, right? Now, if we have the squared y over the x squared, it means I'm talking about m squared. Since the y over the x is m, it means that the squared y over the x squared is m squared. So that's m squared. True or false? So we have m squared plus 5m plus 6 is equal to 0. Right? So that is how it's supposed to be. Now, since the auxiliary equation is a quadratic equation, this is a quadratic. True or false? This is a quadratic equation. True or false? So the value of m can be determined by using factorization, right? Can be determined by using factorization. That is it. Do you understand me now? So if you now say a second order differential equation bets a quadratic equation, of course, we know to solve a quadratic equation, you can use what we call the factorization method. Is that clear? So that is how it proceeds. So in similar ways, when we say the squared y, I'm talking about auxiliary equations here now. When we say the squared y over the x squared plus 3 the y over the x plus 2y is equal to 0. This is also what? An auxiliary equation. auxiliary equation. So I would like for you to calm down, go through the thought process of this video before you start solving. Do you understand? Now, if this is an auxiliary equation where we said the squared y over the x squared plus 3 dy over the x plus 2y is equal to 0, it means that what our what's it called? The equation is the auxiliary equation from here. Sorry, this is a you have not derived the auxiliary equation. So the auxiliary equation here is what? M squared plus 3m plus 2 is equal to 0. You have, at this point, you have converted it to auxiliary equation. Converting to auxiliary equation. M squared plus 3m plus 2 is equal to 0. So since the auxiliary equation is a quadratic, then there is no need for us to panic. So the solution, when you say m squared plus 3m plus 2, by factorization you can have m plus 1, right? M plus 2 is equal to 0. It means m is equal to minus 1 and m is equal to minus 2. True or false? So the squared y over the x squared plus 3 dy over the x plus 2y is equal to 0. It means that y is equal to ae to the power of minus x plus be to the power of minus 2x, which is this and this. So you have to derive from the auxiliary equation. You now factorize and get m, these values of m. Once you get the values of m, you can now substitute them into this. Is that clear now? So that is what we are trying to say. Now, the type of solution that we get depends. Let me put the hand now. We're getting deeper. The type of solution that we get, depends, see that? Depends on the root. Depends on the root of the auxiliary equation. These are things that other videos will not tell you. The type of solution that we get depends on the root of depends on the root of the auxiliary equation. What do I mean? For example, number 1, the first class that we have real and different roots to the auxiliary equation. Real and different roots to the auxiliary equation. What do I mean? Example 1. When we have the squared y over the x squared plus 5 dy over the x plus 6y is equal to 0. This is a very classical example. Let's look at this together. Now, our step 1, S1. Your step 1 is to what? Derive the auxiliary. Derive the auxiliary equation. If you derive this auxiliary equation, you have m squared 5m plus 6 is equal to 0. Okay. By factorization, what you have is m plus 2, m plus 3 is equal to 0. Because what are the two numbers you can multiply to give you 6, and the two numbers you can add to give you 5 is 2 and 3, right? So by factorization, you have m plus 2, m plus 3. So it means that m is equal to minus 2 or m is equal to minus 3. Did you see that? So this is a class where you have real and different. Minus 2 is different from minus 3, but they are real numbers. They are all elements of the number line. Do you understand? They are all elements of the what? Of the number line. Now let's look at another example. Example 2. The squared y over the x squared minus 7 dy over the x plus 12y is equal to 0. Now, what is the auxiliary equation here? Pause the video and try and solve it for yourself. The auxiliary equation here, is what? It is m squared minus 7m plus 12 is equal to 0. So we have m minus 3, m minus 4 is equal to 0. So we have m is equal to 3 or m is equal to 4 auxiliary equation. Do you see that? So then the solution, see that now. Let's bring that into perspective. The solution, see that the solution is of this function now, or of this equation, the solution is y is equal to ae to the power of mx, and m in this case is 3x plus be 4x. Did you see that? That's the solution. So you can see how dicey it is. Now, next one. Let's solve example 3. Example 3. We have the squared y over the x squared plus 3 the y over the x minus 10y is equal to 0. Let's look at this together. What will happen here is we are saying m squared, we are turning the auxiliary equation now. M squared plus 3m minus 10y is equal to 0. Is that not? Remove the y, sorry. Minus is equal to 0. What are the two numbers you can do to get, what's it called? What are the two numbers you can multiply to get minus 10? And you can add. So we have minus 2 plus 5 and minus 2 times 5. Minus 2 plus 5 is 3. Minus 2 times 5 is minus 10. So what we are saying is, we are saying m squared minus 2m plus 5m minus 10. So this is this. So we have m in the bracket m minus 2 plus 5 in the bracket m minus 2. So we have m plus 5 and m minus 2. So it means that m is equal to minus 5 and m is equal to plus 2. True or false? So if m is minus 5 and m is equal to plus 2, it means that our y is equal to ae 2x plus be minus 5x. It is very simple. Do you understand? Now this is for when we have what? Like I said, the class we are tracing now is when we have real and different roots. When we have what? Real and what? Different roots. Now let's look at another example, another class of auxiliary equations. When we have class 2 now, let me call this class 2. When we have real and equal root to the auxiliary equation. Real and equal root to the auxiliary equation. Let's look at this together. When we have real and equal roots, take example. Let's take an example. Our example will be when we have the squared y over the x squared plus 6 the y over the x plus 9y is equal to 0. Did you see that? So converting this to auxiliary, change to auxiliary equation. What we have is m squared plus 6m plus 9 is equal to 0. So you have m plus 3 is equal to 0. That means you have m is equal to minus 3. You have it twice. It's appearing 2 times because m is equal to minus 3 twice. Now this is when we have real, and you see that you have it real and you have equal roots. Real and equal roots. Then this would give an equation that looks like this. You have y is equal to ae minus 3x plus be minus 3x, and their two terms will combine to give you you combine to give you, you now be having something like this. Y will be giving you CE minus 3x. But you see, every second order differential equation has two arbitrary constants. So there must be another term containing a second constant. In fact, it can be shown that y is equal to kx e to the power of minus 3x also satisfies the equation. So the complete general solution is of the form a e to the power of minus 3x plus bx e to the power of minus 3x. What I mean is that all differential equation must be written as this. That's what I'm trying to say. All differential equation must be written as what? Must be written as that. Is that clear? So there should be no need for what's it called? Panic. Is that clear? All right. Let's get into another example. When we have, so let me write examples. If we have the squared y over the x squared plus 4 dy over the x plus 4y is equal to 0. This is a photo pass question. If we have the squared y over the x squared plus 4 dy over the x plus 4y is equal to 0, our auxiliary equation will be m squared plus 4m plus 4 is equal to 0. True or false? So it means that by factorization we have m plus 2 is equal to 0. It means that m is equal to minus 2 twice. Minus 2 happened twice. So it means that the solution is y is equal to e to the power of minus 2x, right? Because normally we're supposed to write a e to the power of minus 2x plus b e to the power of minus 2x, right? That is what we're supposed to have. But I'm now trying to tell you that since this and these are common, right? These and these are common. You can now say that what? You can say that the solution to this is y is equal to e to the power of minus 2x, can be written like this, plus a plus bx. That's what I'm trying to let you know. Is that clear now? That's what we are trying to let you know. So you can write this in this form. Is that clear? Now, another example is if we look at the squared y over the x squared plus 10 dy over the x plus 25y is equal to 0. Of course, the auxiliary equation will be m squared plus 10m plus 25 is equal to 0. True or false? Yes. And so from here we have m plus 5 all squared is equal to 0. It means that m is equal to minus 5 twice. And so if it's happening twice like that, you can now say m plus 5 all squared is equal to 0, such that m is equal to minus 5. Okay, I've written that already. M is equal to minus 5 twice. So y is equal to e to the power of minus 5x into bracket a plus bx. All these scenarios are when they have real and equal. See it there. Class 2. Real and equal auxiliary equations. Real and equal auxiliary. So in photo pass questions, you'll be seeing something like, for example, CBT, ODE. You see something like, which of these is the solution to the ordinary differential equation? Which of this is the solution to the ordinary differential equation? You have something like this. You have the squared y plus 10 dy over the x plus 25 is equal to 0. A, see the question now. E minus 5x into brackets ax plus bx. B, e to the power of minus 5x a plus bx. C, e to the power of minus 3x, ax e minus 5x plus bx minus 2x. Something like this will come out. And so because you have learned from this video, you will know that your answer is what? Is B. You will know your answer is what? Is B. Is that clear? So having said all of these things, let us continue. So photo CBT question. Our next question. Let's look at the next question. This is CBT question. This is CBT question 2019. It says, which of the following is the solution to the ordinary differential equation? So we said the squared y over the x squared plus 8 dy over dx plus 16y is equal to 0. It says A. Alright, so we're trying to pick the questions from here. It says A, y is equal to 4x into bracket a plus bx. B, y is equal to e to the power of 4x into bracket ax plus b. C, y is equal to e to the power of minus 4x into bracket ax plus bx. D, y is equal to e to the power of minus 4x into bracket a plus bx. So our question is, what would you have chosen? Our question begins to, what would you have chosen? So from here, you now know that what? When you have this as a question, you have to turn this to an auxiliary equation. True or false? Once you turn this to an auxiliary equation, you are going to have m squared plus 8m plus 16 is equal to 0. True or false? Now you're going to have m plus 4 all squared is equal to 0 by factorization. It means that m is equal to minus 4 appearing twice. And so from here you know that y is equal to, when they are real, see that? When they are what? Real and equal roots. Is that clear now? When they are real and equal roots, then you can say that y is equal to e to the power of minus 4x into bracket a plus bx. You can see that minus 4x into bracket a plus. So the answer is this. Option D is the correct answer. Is that clear? So that was why I was able to walk you through the steps needed. I was able to. Now we have treated class 1. Our class 1 is that what? When we have first class, our class 1 is when we have real and different roots. How do you write for real and different roots? You just spell it out. You say a is equal to e to the power of minus 5x plus b is equal to e to the power of minus 3x, blah, blah, blah. When they are real, but they are different. Now, when they are real, but they are equal, this is how you write it, right? Now, class 3, when they are complex roots, you see, complex roots to the what? To the auxiliary equation. And we're going to be looking at that very soon. Complex roots to the auxiliary equation. All right, let's look at something interesting. You see, when you have a root to an auxiliary equation that are complex, okay, let's say for example, suppose that m is equal to alpha plus j beta. That is, m1 is equal to alpha plus j beta and m2 is equal to alpha plus j beta. Then the solution to this, see that? Then the solution would be, our solution would be of the form y is equal to ce alpha plus j beta x, right, plus DE. Are you seeing that now? Alpha minus J beta X. Did you see that? And so this will become CE alpha X multiplied by E alpha J beta X plus DE alpha X times E negative J beta X. Sorry for my handwriting. We have EAX, sorry, not AX, alpha this time around. Alpha X into the bracket because this is common to both sides, right? We have CE J beta X plus DE negative J beta X. I know you are not understanding what we are doing. When we use this as an example, you get the full picture. You get the full picture. Now let's look at something. Let's look at an example. Don't forget, we have them in different classes. This is class 3, right? When you have complex roots to the auxiliary equation. Class 3. When you have complex roots to the auxiliary equation. Now example, we have the squared y over the x squared plus 4 dy over dx plus 9y is equal to 0. This is photopass question PQ 2011. The squared y over dx squared plus 4y plus 4 dy over dx plus 9y is equal to 0. 9. Let me write the 9 well. What would this be? Our auxiliary equation is that what? M squared plus 4m plus 9 is equal to 0. Did you see that? So it means that m is equal to negative 4 plus or minus what's it called? Completing the square. That's what we call almighty formula, right? Quadratic formula, where you say minus b plus minus square root of b squared minus 4ac divided by 2a. Is that not? So let's call this a, let's call this b, let's call this c. Is that clear? So what I'm simply saying is that if you find the root of this equation, your m will be negative 4 plus minus the square root of 16 minus 36 divided by 2. And so this will become negative 4 plus minus square root of minus 20 divided by 2, right? And this becomes negative 4 plus minus 2j, see that now, root 5 divided by 2. 2j root 5 divided by 2. The question is, how did I get j? Don't forget, I told you that the j comes in at this point. Your m becomes a plus, you must put that j. Your m becomes this, that jb. Is that clear? So suppose that you have this, then your y will be this. This is what your y will be. So back to this, we now have 2 here 1, 2 here 2. We have our m to be negative 2 plus minus j square root of 5, right? So in this case, right, our alpha is negative 2 and our beta is square root of 5. Yes, our alpha is negative 2 and our beta is what? Square root of 5. So what do we do? The solution to this will now be y is equal to e to the power of negative 2x. You see that? E to the power of what? Negative 2x. That's what I have written here. See, what is your a? Your a is minus 2. That is why it is having, look at it here. Look at the similitude here. So we have a e to the power of negative 2x into the bracket of a, and this is where cos comes in. Is that okay? Cos and sine. We now have cos square root of 5x plus b sine square root of 5x. Cos comes before sine. Cos and sine. All right. So let's look at another example under this class, the class of auxiliary equations that are looking complex. complex roots. As you can see it here, complex roots. Don't forget, complex roots. Now let's look at another example here. Let's look at another example when we have the photo pass question says solve the squared y minus 2 the y over the x plus 10y is equal to 0. Solve this. A y equals ex a cos 3x plus b sin 3x, b y is equal to ex a sin 3x plus b sin 3x, c y is equal to minus e to the power of minus x a cos 3x plus b sin 3x. So let's see which of this is correct. We want to find out which of this is correct. So this is the question, right? This is the question. The squared y minus 2 dy dx plus 10y is equal to 0. So from here, let's get the auxiliary equation. The auxiliary equation will be m squared minus 2m, I hope you are following, plus 10m is equal to 0. It means that m is equal to 2 plus or minus, because we have our almighty formula, or what do we call it? The quadratic formula states that minus b plus minus square root of b squared minus 4ac divided by 2a. Is that not? Okay. So this is a, b, and c. So minus times minus is becoming plus. So 2 plus minus the square root of 4 minus 40. A and c, right? A and c. So minus what? 40. Minus 40. 4 minus 40. A is 1. C is 10. 1 times 10 is 10 times 4. That's 40. Yes. Minus 40 over 2. 2 plus minus square root of minus 36 divided by 2. And then we have 1 plus minus j3. So our y is e to the power of x a cos 3x plus b sin 3x. Do you see that? So that's what we are saying. Do you understand me now? So these are several case studies that you must know. So in summary, our summary says, let me put that now. In summary, right, for every equation of the form, I believe you have your pen and your biro. Your pen, your writing materials should be with you. For every equation of the form a, the squared y over the x squared plus b, the y over the x plus c, y is equal to 0. Always know that the auxiliary form or the auxiliary equation to this will be am squared plus bm plus c. So for number one case study is if the roots are real and different. If your roots are real and different, you are going to be having m is equal to m1, m is equal to m2. Thank God. So your solution there, when the roots are real and different, will be y is equal to ae m1x plus be m2x. Now, number 2, case study 2. If you have a real and equal roots, please take note of these case studies. They are very, very important. M is equal to m1 twice. Then your solution will be y is equal to e to the m1x a plus bx. Now for the last one, when you have complex roots, and your y will be e to the power of alpha x A cos beta x plus B sine beta x. When you have complex roots. I believe that's clear enough. Is that not? All right. Very interesting. Is that not? So that is what we want to look at. All right. That is what we want to look at. Now, meanwhile, there are other things we also need to look at. These are special cases. Special cases. Let's look at a photo pass question. Photo PQ. Yes. Let's look at, we have the squared y over the x squared plus 16y is equal to 0. That's why we should solve this. If you solve this, you are going to have m squared is equal to minus 16. Then you are going to have m is equal to plus or minus j4. Right? Plus or minus what? J4. So it means that your y is a cos 4x plus b sine 4x. You just have to just repeat this for here. A cos 4x, b sine 4x. Example 2. When you have the squared y over the x squared minus 3y is equal to 0. Now don't forget, if you have the y over the x, it can be written as y prime. It can be written as yes, differential. If you have the squared y over the x squared, don't be forgetful. It can also be written as y prime prime, right? Second order, first order. All right, let's differentiate. Sorry. So from here we have this to be m squared equals to 3. Is that not? Because this 3 goes, yes, m squared. Remember, this one is replacing m squared. So m squared is equal to 3. So your m is equal to the plus or minus square root of 3, right? So I'm going to have, when you have this, right? When you have the square root of a number that is not a perfect square, in this case, not a perfect square. When you have the square root of a number that is not a perfect square, it is wise for you to write it as cos. So we have a cos, the square root of 3x plus b sin the square root of 3x. Please, not a perfect square. When you have gotten the auxiliary and you discover that you're having square root of 5, square root of 7, square root of 3, so it becomes what? A cos. Is that clear? That's where cos comes in. Those are special cases. Is that clear now? So let's look at another example. Example 3. When we have the squared y over the x squared plus 5y is equal to 0. What you have now is y is equal to a cos. Now if you take this one to the other side, I'm going to have yes, a, so that's cos, a cos 5x plus b sin root 5x. All right, so that is that about that. Okay, having said all of those, then we begin to talk about inhomogeneous equations. Yeah, we'll see you in our next class when we talk about inhomogeneous equations. Is that okay? Inhomogeneous equations. Glory to God. We'll talk about this in our next class. I want to say bye for now. Thank you very much. Now, meanwhile, when you have questions you want to ask me, please always refer to our WhatsApp. Our WhatsApp is 09058669385. This is Rizzy. Is that okay? All right. Thank you so much. Thank you so much.